Okay, so here we go. Here's the whole process. What's the maximum number of zeros? 4, because it's degree 4. And again, what is the power function? Is going to be 2x to the 4th. It's the term with the highest power. That tells me that since 2 is positive, it is top, has a maximum number of zeros is 4. So the maximum number of times it can cross the x-axis, cross or touch the x-axis. And that it's really a vertical stretch factor of 2 because essentially this doubles the y values. So this thing's going to be pretty steep. But I'm only looking for the zeros, so I don't care. Okay, list all the possible rational zeros. Again, there's a slew of them. The front is a 2, so it's plus or minus 1, plus or minus 2. The back is a 65, so the divisor of 65 are 1, 5, 13, and 65. Would have never thought about 13. So you take the divisors of the back divided by the divisors of the front. You'll have plus or minus 1 into all of them, which gives you 1, 5, 13, 65, plus or minus. Plus or minus 2 into all of them, you'll get 1 half, 5 halves, 13 halves, 65 halves. So all in all, you only need 4. You have 1, 2, 4, 6, 8, 10, 12, 14, 16 candidates for the job, of which only 4 or fewer actually will be there. So we know what to do. The next part of the drill is to narrow the list using our calculator. So this will be 2x to the 4th plus x to the 3 minus 35, x squared minus 113, x plus 65. So check to make sure I've typed it in correctly, because that's one of the errors that I make. And I'm in between minus 10 and 10, so we're going to hope for the best. If we get 2, that means we get it down to a quadratic, which we could use the quadratic formula on. So let's graph this sucker and see how many show up for the party. 1, 2, good enough. And it looks like it's what? 1 half and 1, 2, 3, 4, 5. 5 in the list? Yes. 1 half in the list? Yes. So 1 half and 5 looks to be really good candidates. I'm going to look at things, the other fractions. 1/3 is not in the list. There's nothing around 1 half. When you look at these guys, there's nothing around 1 half. So certainly a half is going to have to be it if it's rational. And 5. So let's check and see. So trace 1 divide 2, 1 half. Yes. 5. Yes. They're both yeses, because I have a remainder of 0. That's using the remainder theorem. So the zeros that I found are 1 half and 5, and that means I already know 2 of the factors. I know I'm dealing with x minus 1 half. That's going to be times some cubic when I start working it down. Then I'm going to peel away the x minus 5. That's going to be times some quadratic. Which, by the way, doesn't factor, because if it did factor, then they'd be rational zeros. So the first thing I'm going to do is I'm going to take away the 1 half. So I'm going to take 1 half, and I'm going to divide it into 2, 1, negative 35, negative 113, 65, and I should have a remainder of 0. So bring down the 2. 1/2 times 2 is 1, and add. 1/2 times 2 is 1, and add. 1/2 times negative 34 is negative 17, and add. Negative 1/3, or negative 130. 1/2 times negative 130 is negative 65, and add. That gives me a remainder of 0. So there's my cubic right here. It is 2x cubed plus 2x squared minus 34x minus 130. That's my cubic. And then I'm going to take the cubic and then break it down into, again, one more time. So that cubic gets divided out by x minus 5, so it's a 5. Bring down the 2. 5 times 2 is 10, and add. 5 times 12 is 60, and add. Five times 26 is more than I want to deal with. I should be 130, and add. So this is your quadratic. Here's the remainder, constant, x squared, so it's 2x squared plus 12x plus 26. So that's what this would be here. And now I need to solve the quadratic. And because I take this guy, set it equal to 0, I'm going to have to use what? The quadratic formula. So that x is minus b plus or minus the square root of b, which is 12 squared, minus 4 times a, which is 2, times c, which is 26, all over 2 times a, which is 2. X is minus 12 plus or minus the square root of, I'm going to go after the discriminant, so this is going to be 12 squared minus 4 times 2 times 26 times 26. Oh, isn't that cute? Negative 64. I like that. So x is minus 12 plus or minus square root of negative 64 is 8i all over 4. Or x is minus 12 over 4 plus or minus 8 over 4i. Or x is minus 3 plus or minus 2i. So we have zeros of 1/2, 5, minus 3 plus 2i, minus 3 minus 2i. And what do we know? If we know the zeros, then we know the factors. So f of x factors into x minus 1/2 x minus 5, x minus, well, this is more than one term, so I'm going to put it in parentheses, minus 3 plus 2i, x minus the 0, x minus 3 minus 2i. But what's the leading coefficient in this case?
2.
Yeah, it's not a 1 like it's sitting here. It is a 2. And by the way, you can tell there's a leading coefficient. What do you have here? You have x minus 1/2. What's the leading coefficient? 2. That's what's sitting here. Once you have a fraction, you've got a leading, and there's nothing sitting in front of here, you've got a leading coefficient.
Is the bottom part of the fraction always be the leading coefficient?
The bottom part of the fraction is the leading coefficient. And here's the reason why. If I said that x minus 1/2 equals 0, that's the factor. If I clear the fraction, multiply both sides by 2, this would say that 2x minus 1 equals 0. That was the factor. Because if you think about it, what would you do? You'd add 1 to both sides, then you'd divide by 2. That's how you got the 1/2. So it's just easier, leave it as a fraction, and just bring down the leading coefficient. That is basically polynomials in a nutshell. I mean, that is everything that we've done in polynomials in one place. And it's all to find the zeros of the polynomial.